Now, before we wrap up, I just want to give one quick review about the uses of these different circuit elements. We've talked about three major circuit elements. We talk about resistors, and we know given a lot of uses for resistors. When we typically start talking about each of these things, you ask, why would we ever design this little device, this little circuit element? What possible use do it have? And so I want to summarize some of the uses that each of these have to give you, now that we've gone through a full discussion about everything we're talking about circuits, what do we learn about how these things can be used? Now, resistors, number one thing is the fact that you lose power through them. Now, that means that the resistors are the only object we've talked about where you are dropping off the power that you generated somewhere else, like in a battery, for example. So that energy might be directly used for heating up an object, like a stovetop is a classic case. We use it, any sort of electrical heating directly is just using the resistance of the resistor to deliver the energy. A light bulb is also like an incandescent light bulb is to good approximation just a simple resistor. So there are those. There's other uses, including that you want to use resistors to control the amount of current that's flowing through an object and where the voltage drops are in a circuit. And that'll be useful for other things like how much charge you have on a capacitor or in an inductor. Now, it also is, remember, the time constant for a discharging or charging capacitor is R resistance times the capacitance. Now, if you're using a capacitor to, say, flash a bright light very quickly, where you dump a bunch of energy in a very small amount of time, you want that time constant to be very, very small. It dumps all of its energy very quickly. So you want to use a small resistor. On the other hand, if you want, for example, to have a long, drawn-out dump of energy, for example, if you plug something out and you want to have a capacitor give you energy slowly in a fairly constant amount over a long time period to take over for whatever energy you lost when you unplugged the device, then you would want a large resistance to increase the time constant. Or if it's important that your current turn off or on over a short or long time period, you can use resistance to change that significantly. Or another, for example, a use you can have is you can measure current using resistors. Ohm's law relates the current through a resistor to the voltage drop across it. Voltage drops are relatively easy to measure. So if you have a resistor with known resistance, you just measure the voltage drop across it. That tells you the current that's running through it. So it's one of the ways you can actually measure current with an ammeter. Now, what do you use a capacitor for? Well, number one idea is you use it to store energy. Batteries provide energy at a constant, slow pace, sort of like a pump provides flows water through a pipe at a constant, slow rate. Capacitors can build up and up and up energy, and then dump it out quickly. So it can store it for a quick burst of energy, and that's equivalent to like slowly filling up a bucket and then dumping the bucket out. So anytime, for example, you have a flash bulb and a light, like if you're taking a picture with your camera, it's probably going to use a capacitor to give a bright flash of light. The biggest capacitor banks I've ever heard of are used to power the most bright lasers, which all go off over a very, very short amount of time, and they use capacitors to store up that energy until they're ready to dump it out at one very brief flash. So if you want a burst of electrical energy, you use a capacitor. Now also, there are times where, for example, if you unplug your computer or turn your computer off, that'll shut down the electrical energy that's being brought into it. Now, your computer would rather not just immediately turn off. It would like to have a little bit of time to perform some necessary functions, to save some information, to gracefully turn itself off, even though you've cut the power. Now, one way of doing that is to have a capacitor in there, and the capacitor will store up the energy while it's running, and then as soon as it loses power, provide that energy back into the circuit and have a limited amount of energy for a short amount of time run the computer before it turns off. And if you've ever seen like those little LED lights that gradually turn off after you unplugged an object, those are being powered by a small capacitor, and that's getting dimmer as you see the capacitor discharge. Also, capacitance is often used as a sensing device. A couple we didn't really talk about was computer keys. Computer keys, the way when you depress them, there are two parallel plates underneath it, one that's in the keyboard and one that's attached to the key. When you push down on the key, those plates get closer together. The capacitance then gets larger, and if you measure the capacitance, you can tell the distance between the keys, and you can tell if a button is pushed down or not. It's also used for a stud finder. If you use a stud finder in the wall, you essentially have two parallel plates that are not parallel, I should say. Instead of being parallel, they've opened up so that they're lie in the same plane. It is not exactly the same setup as a parallel plate capacitor, but it's analogous. And if you put a large dielectric in there, like an insulator, like a big piece of wood, up against it, it changes the capacitance by changing the dielectric constant nearby it, and that then can be registered as the presence of a large insulating object, such as a piece of wood, that's nearby it, even if it's out of sight. So stud finders can use a capacitor, not a parallel plate capacitor, but still a capacitor, and notice how the presence of other insulating materials around it by measuring the change in capacitance. And also, as we mentioned before, with the resonant frequencies, if you have an object that's capacitance changes a little bit and it's being driven by a alternating current at the resonant frequency will shift, leading to a drop in the power because now the power supply is not at the resonant frequency, and you'll have a very loud, noticeable change in that case. Or in any of the case where we use resonant frequencies like the AM radio, they use capacitors. Also note that you can add a capacitor to change your driven frequency, like if you plug it into a wall, 120 hertz is, 60 hertz is the frequency of the wall frequency. And when you if you're hooking something in there and you want it to be at the resonant frequency so that maximizes the power output, and you already have an inductor, if you add a capacitor, you can shift the resonant frequency down to the frequency where down to that 60 hertz, giving you increasing the amount of power output of that object. Okay, inductors are used. Inductors are a good model for an electromagnet. So anytime you want to make a magnetic field with a current, you can think about it, if it's being hooked into a circuit, as an inductor. Well, one case, for example, where you could use that would be a starter solenoid. A starter solenoid is inside cars. I'm not sure if modern cars have this or not, but a classic way of starting your car is to have a current run from the battery into a solenoid that generates a magnetic field. That magnetic field then pushes on a piece of metal, like a piece of iron, magnetic material. It'll shift it into a position that closes a switch that then allows the engine to start. So it's essentially it's a case where you can go from electrical energy, like a current, so you get electric potential energy being used to push on an object, in this case to push on a piece of iron to close a switch. So it's sort of like a motor in that sense, and an actual motor also is an electromagnet as well. But an inductor can be used to take current and use it to push on an object. Also, inductors are present anytime you have a generator or a motor. There's a lot of times you want to generate electricity or turn electricity into a torque, which is what a motor effectively does. And also, you need an inductor to have that resonant frequency for AC alternating current, and things like AM radios and many of these detectors, as I mentioned, rely on having that big change in power as the resonant frequency changes. So those are some of the uses. There are many more uses than I've listed here for these three circuit elements, and why we bother even talking about them.